Hi, in today's video, we will be discussing two key terms, or we will be discussing analysis. Correlation analysis in statistics. When we talk about correlation, in statistical terms, it's a relationship, it's describing a linear relationship between two variables. And when we speak of variables, normally we refer to an independent variable and a dependent variable. By linear relationship, we refer to whether that relationship between those variables increases or decreases at a constant rate. So it's really a correlation is a relationship between two or more variables in simple terms. Now, normally in statistics, we describe relationships as either being or as having a negative correlation or as having a positive correlation. Now, when we say that the relationship between two variables has a negative correlation, what that means is that the relationship goes in different directions or in opposite directions, for want of a better word. In other words, as one variable increases, the other variable decreases. For example, let's say we look at the number of hours watching television and we compare that with your grade on a statistic test. The more time a student spends watching television, which is the more time that variable is increasing, his or her grades will decrease. So as you see, one was moving up, which is the number of hours watching TV, and another variable was decreasing, which was the grade for that particular statistics class. If we were to consider another example to give some context, let's say, for example, we look at the number of crimes per capita that has been found to be related to the number of police in a specific area. When more police officers patrol a particular area, crime tends to be lower, and when police officers are absent in that area, crime tends to be higher. And so in both examples, in statistical terms, we say the number of police officers and the number of crimes have a strong negative correlation because the relationship between both variables move in opposite direction. Now, when we say that two variables have a positive correlation, that means that as one variable increases, the other variable also increases, or when one variable decreases, the other variable also decreases. So let's consider an example. Let's say we consider the number of times a cricket chirps per second. A cricket is a tiny insect. So we're looking at the number of times a cricket chirps per second and its relationship to temperature. When the temperature is cold, the cricket chirps less frequently. And as the temperature increases, the cricket chirps at a steadily increasing rate. And so with this example, in statistical terms, we say the number of chirps done by the cricket and temperature have a strong positive correlation because as one variable increases, the other variable also increases. I forgot to move the slides. Now, a lot of times in order for us to measure the relationship between these variables, we have what is called the correlation coefficient. The correlation coefficient, which is understood as a small r, measures the strength and direction of a linear relationship between two variables on a scatter plot. That's an error there. That letter T should not be there. The values are usually between +1 and -1. +1 means that there is a perfect positive correlation between both variables, and -1 means that there's a perfect negative correlation between the variables. So how does that look on a scatter plot? The further apart they are, it means that the relationship is not as strong. The closer they are together, it means that the relationship between both variables is strong. So that's it for today. Just a little synopsis of two key terms. What is correlation analysis and the correlation coefficient. Thank you.